As you all know, an explosion with a power about 1/5 of the atomic bombing at Hiroshima took place in Beirut on August the 4th. Let's all pray to God that this will never ever happen again. And in this video, we're going to talk about some scientific aspect of this explosion, since some people asked why there's mushroom cloud when it's not a nuclear bomb. And in fact, mushroom cloud is not specific to nuclear bombing. So we're going to talk about how mushroom cloud forms, and we'll talk about the shock wave that comes after, which is the most detrimental part of the explosion. Also, we'll talk about how to increase your chance of survival in this kind of situation. Let's get started. So, how does a mushroom cloud form? Let's say there's an initial explosion near the ground, and the explosion will greatly heat up the air above it, and the hot air will arise. And as the hot air arises, it'll leave almost a vacuum near the ground, and the vacuum will draw in the cold air together with debris and dust, and the cold air will further mix with the hot air, and together they forms the stem of the mushroom cloud. And as the hot air keeps rising, eventually it will encounter friction from the upper level, almost stationary atmosphere, and the friction will slow down the air current, especially the middle part. And according to Bernoulli's principle, when the speed of the air decreases, the pressure will actually increase. So the middle part now has greater pressure. It will exert pressure gradient force to the side, which will push the air current to the side. And since the pressure gradient force is always perpendicular to the velocity of the air current, it will actually force the air current into a circular motion, and the air current eventually will re-enter the stream and forms the head of the mushroom cloud. So you can see the mushroom cloud is not specific to atomic bombing. It can form during any large-scale explosion. Okay, next, let's talk about the shock wave. And as you can see, the mushroom cloud really is not the part of the explosion that's doing most of the damage. In fact, it's the shock wave that comes after the mushroom cloud that's doing the damage. What you're looking at right now are shock waves from this explosion at Beirut. You can think of shock waves as highly pressurized air bubbles that travels at a really high speed. If it gets to buildings or humans, it can cause irreversible damage. However, shock waves are not only specific to explosions. You actually see it during a rocket launch, and you experience it when a supersonic airplane flies over. So let's use the example of airplane, which is more familiar to us, and talk about what is a shock wave. So when the airplane is not moving or is traveling at a really low speed, it sends out sound waves in concentric circles and evenly distributed. However, if we increase the speed of the airplane to a high speed, and then you're able to see the sound waves in front of the airplane get compressed. This is the Doppler effect we talked about in Physics 11, and this is due to the source of the sound is also moving, so the sound waves in front of the airplane doesn't have time to get away, so they get compressed. And if we increase the speed of the airplane to the speed of the sound, or 1 Mach, then all the sound waves will actually compress into one single shock wave, which are really powerful wave. And if the airplane speed exceeds the sound speed, then all those waves will be forced to collide onto each other, which will generate more shock waves that are basically highly pressurized air bubbles, very energetic, and can cause sudden change in pressure in the air. You will also be able to hear the sound associated with the shock wave that we call the sonic boom. So, if you happen to be near it, then the shock waves may damage your bones, your ears, and your inner organs. And those shock waves are similar to the ones generated by the explosion. It's just that the shock waves from the explosion, especially like the one in Beirut, can be a lot more powerful. So whenever a large scale explosion happens, the speed of the burn will exceed the speed of sound. And that means there's going to be shock waves generated in all directions, which will cause great damage to buildings and humans with a radius of tens of kilometers. So now let's talk about how do you increase your chance of survival in this kind of situation. If there is for example, intercontinental missile attack, and if you're within 12 kilometers, there's really not much you can do about it other than pray to God. The most survivable zone is at least 30 kilometers away, and if you are outside, you should duck down to the ground as soon as you see the light, so that you can protect yourself from the following shockwave, since light travels faster than sound, and it can give you a couple of seconds that are important for your survival. And remember to always point your head and neck away from the explosion, cover them with your hands. And if you're inside, hide under a table. Going underground, such as into the basement, would be your best bet, compared to running on the street away from the explosion, since the shockwave travels a lot faster than you can run or drive. But really, let's pray to God that this kind of disaster will never ever happen again.